discussing the library of the function and the transformation, is the topic of today. Okay. This is the example number 1 for today. Let me recall something. Recall, important recall. To find the domain in any function, when the formula, when the expression is given, you have 3 kinds of restriction. Restriction 1, P divided by Q not 0, because you know it's illegal division by 0. Number 2 is radical E. E represents expression. This expression must be non-negative, the positive or 0. And number 3, que es a combination 1 and 2 together. Suppose que es P. Record. Laura, you did the record?
Yes.
Thank you. P divided by radical E. E must be positive. No 0 because 0 in the denominator. And, of course, they are combination. Entonces, es expression in the denominator, no 0. Expression inside the radical, non-negative. Expression inside the radical, but in the denominator, just positive. In this case, the option 3, you see 1 radical in the denominator. Therefore, the restriction, so the agreement que you suppose for the domain by definition is the set of value of the x in which the function is defined. So si es undefined, es out the domain. So you suppose the domain is all real number, the agreement is all real number. Except restriction. And the restriction all real numbers except the restriction. And the restrictions is that part. That part, que I recall, was the restriction. So in this specific example, number 1, I can see that we have a radical in the denominator. It's a restriction number 3, I suppose, like that. So you take the expression inside, is x minus 9 is greater than 0, and you solve this elementary inequality, x greater than 9. And also, always, you express the final answer using interval notation. Guys, in the test, I don't want another notation, only interval notation. Interval notation is the notation that you separate by a comma, and you put a bracket or parenthesis, include it, you do not include it. So you are not sure how it look like that. You are doing the sketch in the all real number line. It's a 0 in the middle. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Here is 9. It's from 9, but to the right. It's to the right and in that direction. And do not include a 9 because I don't see equal sign. No equal sign, no include a 9. Entonces, the way to indicate that is parentheses. The answer is domain is equal 9 parenthesis comma infinity. Remember, infinity or negative infinity, you never put the bracket because infinity is a symbolic way to indicate that this continues forever in that direction, no? And you never reach. Any question? In the example 1. I bring 2 more. It's okay? You copy that? You want to make it soon? Copy. Take a picture. A screenshot. Good. Let's move on to example 2. Example 2 is interesting. It's h of x. Remember function notation. You put the name of the function key. I want to call h. And the expression is x over x squared plus 1. Okay. This looks like a p or a q because we have no radical, no? So the denominator Impossible to be 0. It's illegal to be 0. Now you take this expression x squared plus 1 equal to 0. I put no equal to 0. You put equal if you want. But much better put equal to 0 because I am familiar with the solution for the quadratic equation. Actually, I know that the solution is the restriction, is the bad guy. So my domain is all real number except the solution for this quadratic equation. No? Now, I solve for this. X squared equal -9, -1, sorry, square root both sides. I can see that the answer is plus or minus I. When the answer is imaginary or complex, no? Es similar idea, no? That means it don't belong to the real number. And remember the domain and my supposition is all real number except the restriction. But I discovered that the restriction is imaginary. The restriction living in another planet, not in our planet. Therefore, we have no restriction in the real field. Therefore, the domain of the function h of h is all real. Any question? Because the answer is imaginary or real. So in algebra, normally, when the answer is imaginary or real, that means that do not exist. In this case, do not exist the what? Do not exist the restrictions. Therefore, we have no restriction to say it's all real number. So I guarantee you that any real number you plug in here and here, always give me a number, no to be undefined. No error, no mistake. Do you understand the example number 2? Guys, I need feedback. Are you sleeping? You are awake? Okay, you understand? Come on in the chat. Use in the chat. Yes, no. Okay, you put the sum up. They understand. Sum down. Say I don't understand. And what part you don't understand? Okay, up. I see. Jordan is everything is okay, professor. Come on, Andreina. Come on, Rosalinda. Come on, Jasmine. Come on, the female. The female. I am good. Okay. Okay. Super. Okay, got it. Okay, super. One more example. Number 3. Number 3 example is G. Is the name of it. And this is a square root uh-huh, 2x plus 1. What happened, Junior door? You are inside the Skype. X minus 4. Suppose this. Wow. So this is more complicated because we have radical and we have denominator, no? So we have, remember, when you have denominator, the denominator no 0. So this is denominator. This is Q expression. So in our example, Q is x minus 4. No 0. And we have radical, pero depende si es radical in the top or radical in the bottom. In this case, radical in the top. Okay, nice. Entonces, easier is a E, capital E expression, non-negative. I try to use a computer. Okay, try. There are many ways to watching the lecture by smartphone. So people are using smartphone. I know people using laptop. I don't know if people using computer. I don't know if some people using tablet. Entonces, this is, you take the expression in the denominator inside, que es 2x plus 1. And this expression I know que es greater than or equal to 0. So we have one restriction for the square root, and we have another restriction for the denominator. And we connecting this inequality que form my restriction by or no by and. By or no by and. By and, because you need to satisfy this condition and this condition. Okay. Okay. Then let's solve it separately. Okay. This is x. I move 4 to the right hand side. No 4. Okay. This is a whole. And this is inequality. I move subtracting 1. It's 2x. The one disappear, -1 divided by 2, x is greater than or equal to -1. Okay, so now as always happen, in this moment you have one compound inequality is formed by one inequality and another inequality. I try to find the total solution, and the total solution is the index. Hey, what's going on? No noise.
Professor,
¿Qué pasó? What's going on?
can you speak up so I can take a picture?
A ver, I don't hear. Come on, speak loudly and clear.
Can you scroll up so I can take a picture?
Okay. Let me know when you finish to take a picture.
Thank you. I got it.
Okay. Now, I try to explain now that in this moment, we have a compound inequality. The compound inequality formula, let me recopy again. It's no 4 and x greater than or equal to -1. But you cannot leave it like that in the test. You need to express it using, remember, the famous interval notation. Entonces, I recommend always, when you solve a compound inequality, the last step is do the graphic representation. And when you finish the graphic representation, you see clear. This is my all real number line. This is 0 in the middle. 4 is 1, 2, 3, and 4. And -1/2, I suppose que it's a -1, no? Es here. -1. Entonces, it's greater than that part. Let me use a different color to emphasize the idea. That part, the blue color, represents the value of the interval greater than -1/2. Entonces, to the right, no? To the right. To the right here, to the right here, to the right. Let me use in this symbolic way to indicate the temporary answer after I highlight the true answer. It's here and of course include -1/2 because I can see equal sign here. But here we have a hole. Here we have a hole because it is all real number except 4. So in 4 we have a hole like that. Okay, so what is my final answer? Well, my final answer is from -1/2, stop in 4, no 4, and continue from 4 to infinity. Okay? This continue forever in that direction. Here is square bracket. So the answer is domain is equal bracket -1/2, comma 4, parentheses, because do not include 4, union 4, comma infinity. Okay? 4, comma infinity. End the story. How do you feel? How do you feel? How do you feel in the domain? This is one question in the test. One, I got it, okay. One expression is given, and you need to investigate its domain algebraically, using the restriction, the set of the restriction. That's it. Okay, let's move on to the topic today. The topic today is the library of the functions. I want to present to you the most important function that we study in college algebra, and we are doing today transformations. Okay. I go to the decimals because I have in decimals. Okay. Let me switch into decimals. Okay, there you go. Okay, you need to be familiar a little bit with the name of the function. Look, the name of the function is, remember that you have one piece of paper and Word. They have the same information, but you want to see now using in decimal graphically. If you want, why not? I can send to you this link and you see in your own computer the function. The function is 1, 2, 3, 4, 5, 6, 7, 8, 9 functions. The most important function, okay. Constant function. Constant function is a piece of cake. It's a line. The formula is y equal any number. In this case, 2.4, arbitrary number. Okay? In this case, you can see that the domain is a real number because the extending in both directions from negative infinity to positive infinity. Okay, this is the elementary function. The other function is identity function. Identity function is a line. It's a line y equal x. It's a line can be set the first quadrant and the third quadrant. So you need to be familiar with the name, identity. You need to be familiar with the equation y equal x. And more information that we can see throughout the course, domain, range, and another information that you don't know, increasing, decreasing, even, odd, que es another information we study another day. But I present just name and an equation que represent the function. Okay, this is the identity. Remember, identity. This is very important. Quadratic function. Quadratic is a parabola. It's a famous parabola. It's a famous parabola. Look at the parabola. Parabola look like that. Open. In this case, the parabola open up. And the basic equation, the basic. I promise in a few minutes, I complicate your life because I want to make a transformation. But this is the basic. This is the mother. This is the main, the most important. After we can see transformation. So y equal x squared. It's a parabola open up. Okay, quadratic. Cubic. Y equal x cubic. Let's look like different, completely different. It's right up, left down. Quadratic, no, quadratic is, let me see, quadratic, the behavior, the end behavior is right up, left up. It's the behavior. End behavior. A square root. Look at the square root function. Square root is y equal radical x. We have no, in this function, we have no the negative part. So our domain is from 0 to infinity. Why? Because when you plug in a negative number inside, give me imaginary number. Therefore, domain and range of both are positive number. So from 0 to infinity. Include zero, so bracket 0, infinity. Okay, this is square root. Next, and the list is cubic root. Oh, cubic root. Cubic root is like that. Cubic root is different because cubic root allow positive and negative number. This is confusing for you or no? Okay, let me try to switch into the board to explain why cubic root allow negative number and square root no. Okay, I want to switch into the board again. Board. I suppose you see the board now? Okay, I want to erase the board. I want to explain what happened with the square root and the cubic root and what is the difference. Suppose the function y equal square root x. Suppose x equal negative 25. Y is equal square root negative 25. It's obvious. Is pi. And this is imaginary number is out of the domain. Therefore, the domain of that function is bracket 0, infinity. That do not allow negative number here inside. No, it's imaginary. The answer imaginary is not acceptable in this chapter. It's a guy living in another planet. However, what happened with the cubic root? It's different because suppose x equal minus 27. Okay, y equal is cubic root negative 27 is negative 3. Why? Because negative 3 times negative 3 times negative 3, 3 times is negative 27 is exactly the number that we have inside the bracket. Negative 3 and negative 3 is positive 9. Pero positive 9 and negative 3 again is negative 27. Here no. Here no. The only possibility that give me negative 25 can you multiply 5i times 5i, que es 25i squared. Yeah, I know by definition I squared is -1 and -25. So the only number that satisfies this is imaginary, and imaginary is out the domain. The domain. However, cubic rule, no. Cubic rule allow positive and negative number inside. It's fantastic. That is the reason. That is the reason. That is the reason that the curve of the cubic root have to branch, and the negative part and the positive part. Look at that. Do you see? Let me put in the projector mode to see much better. Look, in the negative part, in the positive part, sorry, in the negative. This is cubic root. Reciprocal is the next in the list. Reciprocal is the famous function 1 over x. 1 over x. So 1 over x is nice because 1 over x, the only restriction we have is when the x is 0. So in 0, the curve never touch. So the domain is all real number except 0. Because what happens in 0? 1 divided by 0, undefined. Not good. Okay, so it's a reciprocal function and it is more or less nice. Absolute value. Absolute value is the famous absolute value that we studied in the first chapter. Remember, absolute value represents the distance. Absolute value always give me a positive number, right? Entonces, es regardless si the value is positive or is negative, the y value is always positive. Okay, this is the absolute value. See, for example, I ask you, what is the domain? The domain is already a number. We have no restriction. What is the range? Oh, no, the range, no. The range, que the set of the y value is just positive value, never negative. Never we have value here and negative. Okay? And finally, one function que is a curiosity. I never put in the test something like that because it's very, very complicated. But it's okay. It's the function floor, or I call it, there are different names to this function. It is the graded integer. Graded integer. I want to explain, but on the board, right? Look like stairs. Look, stairs. Let me explain the basic idea. It's easy. It's relatively easy. Let me explain now. The basic idea for the floor function, or graded integer, or just integer. It's a different name for this weird function. Okay, board now. Switch it to the board. Okay. Okay, let me explain the floor function. Floor. There are different names, guys. Floor is one name. Floor of x. Another name is integer, like that. I see in some book. Oh, that symbol is weird. But it's the same idea. Different name to call the same idea. Let me explain the idea for the floor. The floor 0, 1, 2, 3. This is all real number line. -1, -2, -3. Suppose I want to find here in the middle 1.5. And you could build the floor of 1.5. The answer of this, is only integer. Integer number is not real. Integer number is 0, 1, 2, 3, -1, -2, -3, 4 positive, integer. No fraction, no decimal. But you take of the collation for any integer number, you take the value gets greater pero below 1.5. You need to find, o sea, less than 1.5. So in that direction, you take the greatest, and the greatest is 1. The answer of this function is 1 in 1.5. is confusing, is 1. For example, floor, 1.6, it's also 1 because it's here. Okay? Floor, 2.5. Here, 2.5 here. Esto. Do you understand? Floor, 2.6. Esto. Okay, this is the idea. That is the reason que look like stairs. That the number in between 1 and 2, the answer is 1. The number between 2 and 3, the answer is 2. And so on. The number between 0 and 1. Let me see what happened in between 0 and 1. The floor function of, for example, 0.4 is 0. 0.4 is here. And the collection for the integer number is 0, less than that number, of course. It's 0, -1. Entonces es 0. 0, right? 0 gets this. Okay, likewise, floor of 0.5 is 0. Do you understand or no? Or confusing? Very confusing, eh? Clear or confusing? Let me check if you understand or not. And you answer me using the chat. Clear? Okay. Launa is a smart student. Let me try. Suppose floor of -0.5. Who help me? What is the answer of this? 0. Everyone is agree 0 is 0. It's 0. It's not 0, guys. 0 is your grade. Okay, -0.5 is here. Yes or no? And the collection of the integer number less than -0.5 is 1, and -2, and -3, and -4. And the greatest is -1. The answer is -1. Yes or no? Do you see or no? Okay, another, the last example. -1.2356. What is the answer of this? -2. Very well. You're right. Super. You got it. -2. What's happened? What's going on? It's -2. No, Rosalinda, no -1. Look. 1.23, I suppose que here. And the number less than this quantity is -2, -3, and you take the grade. It's -2. The answer is -2, no -1. But don't worry, guys. It's not important. Maybe in calculus, you see again this in one sophisticated example, but it's not important. The most important is, let me summarize quickly, the most important, the name of that function. You need to be familiar that in the paper I sent to you, you have name, equation, domain, range. Okay. Suppose the first one. The first one is constant function. Constant. And constant is y equal any number, 5. That is a horizontal line. The second is identity. Identity is a line, y equal x. It's a line passing through the origin, look, and bisect first quadrant and third quadrant. First quadrant, third quadrant. Number 3 is super important. I like so much. Quadratic. Quadratic is a parabola, guys. The parabola is very, very famous like that. Open up. Let's see different options. Open up, open down, open blah, blah, blah. But this is the basic. This is the basic. We studied the basic without transformation. Number 4 was cubic, no? Cubic is y equal x cubed. X cubed look like that. Number 5 was a square root. Square root is square root. And square root is classical. It's in only one direction. We have known nothing in the because the domain of this is only positive number. No, from 0 to, the domain is from 0 to infinity. And number 6 is a cubic root. Cubic root is nice. Look like that. It's similar to the square root, but in both directions. And next is absolute value. No, reciprocal, sorry. 1 over x. It's weird, it's something like that. But domain is all real number, all real numbers, except the by guy gets 0. The denominator is 0, not good. And finally, number A is absolute value. Absolute value will look like a B, the graphic. Pam, pam. Okay, domain is a real number, but the range is only positive value. One more information we need. Well, the graph, the name, the graph, the equation, that's it. You understand very well? Super. Okay, let's go now, move on to the topic we covered today. Gets a little bit complicated. Very, very complicated. Please pay attention. Any question, let me know, but let me finish the explanation. Okay? Transformation. Transformation, basically, we have 4 kinds of transformation. Only 4. Only 4. Let me try to find in Desmos the application for the transformation. I have it. Okay. But let me go back to the board. Do you see the board? Do you see the board now?
Yes.
Okay, good. Okay, let me start for the transformation. Look, transformation. We have 4 kinds of transformation. Number 1, F4. The first one gets easy. Everyone understand clear. Is, for example, you have a function. You have a function. And you adding plus or subtracting, maybe. One number here, A. Entonces now, this transformation, when you adding or subtracting, because maybe this A is positive or is negative, give me que the graph having one vertical shift. Es obvio que si A is a positive, the vertical shift is up, and si A is negative, the vertical shift is down. Okay? Let me try to see. I create animation, I create a slider in Desmos, and you can see clear now. Look. Okay, it's switching to Desmos. Okay, the function que I create for you. Well, basically we studied 2. But the first one is the parabola, the basic parabola. Look, the basic parabola. This is the basic without transformation. And the transformation that we study now is called vertical shift. And vertical shift is the parameter A. Look, the parameter A. When I change the parameter A, suppose I change to the positive value, look at what happened. Sorry. No, the problem was que you graphing the basic, but you graphing now the transformation. And red color, the same color. When you are doing now, let me change the color. Let me put black color. Black color. Do you see they are perfect coincidence? Because we are doing nothing in transformation. Now, however, see you move A to the positive. Oh, vertical shift. As you put a negative value, vertical shift down, vertical shift up. I suppose everyone understand very well this. Yes or no? Yes or no? Let me come back. Let me come back to the board. Yeah, you understand? It's clear. It's easy. This is nothing for you. You understand very well. Okay, guys, the explanation, the reason why is in that direction, well, it's obvious. But however, okay, suppose que the point at the beginning is x comma y, no? Arbitrary point on the, and when you are doing a transformation, whoop, the x stays the same, Y stay the same because I modification, this A is applied in Y, not in X. So I don't adding or subtracting, can see the board, no? A ver, let me see. Laura. Okay. Oh, yes, you are right. Okay. Now, it's okay?
Oh, yes.
Yes, okay. The thing I tried to explain was, let me erase everything except the last part. I tried to explain why the motion is vertical and why the motion is up or down. The reason is, suppose que in the basic function, we have one arbitrary point I call x comma y. And the new one, when you transformation, you are doing a transformation, x stay the same because you adding a in the y value, not in the x value. So you adding here inside the parentheses. Entonces es different. No, we see after that. So this is basically, o sea, es one specific example. Suppose y equal x squared, quadratic function, and y equal x squared plus 2. What is the difference between this curve? This is the basic parabola. Boom. Well, this is plus 2, is plus 2, moving up because of plus 2. So basically, the formula, do you understand, and the point, plus 2, plus 2, plus 2, is que you, y value of this y value, you adding plus a. Makes sense, right? X stays the same, x stays the same, but y no? Y is increasing. If it's increasing, the motion of the transformation go up. Si es minus, because I suppose que this a is negative, suppose y equal x squared minus 2, entonces the parabola is going down. Okay? Everything is clear? This is vertical shift. Everyone understand vertical shift? Yes, everyone understand vertical shift. Always the student understand very well vertical shift. But I want to complicate your life. Now, I promise. I try to do my best. Easy. I try to do my best, but I know it's hard to understand. Suppose another transformation. Remember, we have only 4. The second one is horizontal shift. So horizontal shift is different because we have a function, the basic function. This is the basic. But the transformation that we are doing now is you adding or subtracting, but inside the parentheses. Okay. So I suppose, using my common sense, the shift is not vertical, no, it's horizontal. And horizontal, we have only 2 directions, right or left. So the motion of the curve is maybe to the right or maybe to the left. I don't know. I don't know very well. I'm not clear. I'm not sure. Dependency is positive or negative because sometimes the intuition is not good in this example. Let me try to go to Desmos. In Desmos, we can see in what direction it is. Okay, I switch into Desmos now. Desmos. Okay. Do you see Desmos? You see? Yes or no? Yes. Okay. Entonces, A es 0. A is 0. So no vertical shift anymore. No. No. Now horizontal. And horizontal is using B. In the formula, look at the formula. The formula, in general, I put a B here. Forget about D and C. D and C is not important now. D and C is 1, 1. 1 is invisible. But B is 0, so we have no transformation. However, pay attention now. I want to change B. Si B is positive, the motion is to the left. And si B is negative, the motion is to the right. Do you see the effect or no? Do you see the effect or no? Yes, but you don't understand very well, no? You believe it's completely opposite the first time, or you accept this idea? Eh, guy? You accept that this is correct? Accept. Okay. I respect. Do you see the board now or no? The board now? A ver, I'm confusing with the switching board. Okay? No, I save time. Si you understand this, no problem. Okay, entonces, what is the conclusion? The conclusion of the horizontal sheet is, I don't understand. Okay, super. It's exactly. Jonathan, super. Let me prove, Jonathan. Let me prove algebraically. Suppose in the original basic, this is the new one. I call 1 point y1, and this is x1. And the new one, I call y2, and this is x2, pero plus b. In that. Entonces, in order to compare the point, I know that the motion is horizontal, in that direction. Never vertical. No. Never vertical. Es horizontal. Entonces, in order to compare two parabolas, suppose this parabola and this parabola, I take the same y value. I assume que y1 and y2 is the same. This is supposition. Therefore, x1 is equal x2 plus b. Make sense, right? See, this is equal, should be equal this and this. You solve for x2, entonces x1 minus b is equal to x2. Conclusion. The x2 is subtracting b. Suppose this is x1. Well, let me try to do one more interesting sketch. Suppose the parabola like that, and another parabola is like that. And suppose that this point contains x1, x1. Entonces when this plus b, x2 is here. Okay, it's smaller because subtracting b. So if b is positive, the motion is to the left. However, if b is negative, double negative becomes positive, the motion is to the right. I don't know if it's clear for you, mister, or no. It's clear? A little bit? Entonces let me summarize one important idea. When you perform operation or transformation inside the parentheses, in the graph you see completely an opposite operation. Si es plus, es minus. Si es plus, es left. Y si es minus, es right. Because si es plus, in the graph is subtraction. Y si es minus, in the graph is addition. Let's see after when you are doing another more sophisticated operation inside. You see when you operate inside the parentheses, it's opposite operation. Suppose que multiplication is division. However, outside, no. Outside is the same. Si es plus, up. Si es minus, es down. Super. So in Y, the transformation is exactly in the same operation that you should do. So your addition is up in the Y. So your subtracting is down. But in the X, when you operate it inside the parentheses of the function notation, here, you introduce, for example, 2x. Or you introduce here x plus 2. Actually, it's minus in the graph. Okay? In opposite direction. A little bit clear or confusing? A little bit clear or confusing? A little bit clear or confusing? So basically, we have so far two transformations. Vertical shift is up or down. A little clear. Okay. I understand very well. You need to processing a little bit this information. Now we have horizontal shift. The horizontal is left or right. When it's positive, left. When it's positive, is left. When it's negative, is right. Okay. But we have more. 3 and 4. 3 first. 3 is vertical. Stretch. Compress. And reflection. So we can create these 3 effects. And this is, for example, when you have a function, suppose y equal f of x, and you multiplication this by one factor. Suppose this is the basic without transformation, and the new one after the transformation is y equal c multiplied by x. Example to understand this. Suppose the basic parabola, nice, what you multiply by 2 or by 3, and this is a c value, or by half, or by 1/4, or 3/4, or 4/3. And this is what happened. What's happened? Okay, what happened when this factor? What do you think it happened? Okay. I need again. This is a little bit complicated. This is my basic parabola, chung chung. Without transformation, y equals x squared. What do you suppose can happen when you multiplication by 2? My parabola. This new parabola is no motion. It's not because it's motion when you adding or subtracting. But when you multiply, you are doing like a zoom in or zoom out. O sea, es stretch or compress. What do you think it happened? This new parabola is a wider like that or it's narrow like that? A stretch. Okay. Jordan say a stretch. I agree with him, but I need to understand very well the meaning of this word, stretch. A stretch is my new parabola now is wider or narrow. What do you think? Opinion? No opinion? Nobody? Wider. Jonathan say wider. Okay, the student believe que es wider. So one wider, Alejandro wider, narrow. Nobody narrow. Wider, 3 people. Jordan wider. Launa wider. Narrow, Rosalinda. One, who more? The rest, no opinion. Andreina is an arrow. Okay. 1, 2, 3, 4, 5 wider. And only 2 narrow. Wow. Let's see what say decimals. I want to verification algebraically after that. Okay, I have no idea. Okay, no problem. However, I go to decimals. The decimal help me to understand this problem, si it's wider or is narrow. Do you see what decimal? Do you see? Okay, entonces I want to make B0. I want to make B0 because we have no horizontal shift, no horizontal shift. Yeah, I want to change C. It's a factor que multiply. C, a factor. Look at what happened. Pay attention. When I increasing, see, narrow. When I decreasing, for example, this is 3.7, 4.2. Suppose now is a number less than 1. Suppose 0.6 is wider and wider. But I have more for you. I can make it soon. Now, if you change the sign of the C, we are doing reflection. My parabola open down. Now, my new parabola after the transformation. Specifically, si es -1, let me change -1. -1 is exactly reflection. It's just reflection. Flip it. That's it. Okay? Let me go to the board because I want to explain anything. Okay. To explain this in detail, I propose one idea. Okay, I propose one idea. I propose do. Okay, I want to compare. Suppose x. Suppose the parabola basic, x squared, and suppose the parabola new, que es 2x squared. Yeah, I put arbitrary values, suppose 0, 1, 2. And the first one is 0, 1, and 4, no? Because 2 squared is 4. And the second is 0 again, but this is 2, because you multiply by extra 2, no? And here you multiply is 8. So you are doing the graph of the basic is 0, 0. No, everyone passes through 0, 0, 0. This is y value I. Y value 1, y value 2. And this is x. 0, 0 is common. 1, 1 is for the basic only. 1, -1 is symmetric, and 1y. This is my parabola, my basic parabola, my nice parabola, my mother in the family of the parabola. But the other, no. The other is 2. Okay, 1, 2. 1, 2 is here. 1, 2 is here. So I suppose you plot 4, 6, 4, 8. This is the parabola y equal to x squared. Do you see? Now? You see now? ¿Es wider? Ajá, entonces, what is the conclusion? What is the conclusion? The conclusion is que this transformation que we studied, by the way, is the third one. We have stretch, compress, or reflection. Ajá, entonces, okay. If C is greater than 1, si C is greater than 1, we have a vertical stretch. It's vertical stretch. Suppose one in this example was C equal 2, no? Was vertical stretch. Do you understand what means vertical stretch? Vertical stretch means, suppose to understand very well vertical stretch. Suppose que this is my face, professor face, and you multiply my face by 2, pero no by 2 in x and y. You multiply only in y because it's vertical. Because my new face now is like that. Do you understand now? And this is vertical stretch. So you multiply my face again by 1/2. This is my new face. I suppose I don't do well. 1/2 is compressed. So if Z is a number in between 0 and 1, is vertical compressed. And if C is -1, is reflection. But be careful, it's reflection about x-axis. Okay, what mean about x-axis? About x-axis means, I make a mistake. Okay, undo again. Means if my parabola, basic parabola, is like that, my new parabola, so this is y equal x squared, for example, and my new parabola is like that. Let me change the color. This is y equal minus x squared. When the coefficient is -1, occur the reflection, and the x-axis behave like a mirror. Look, hey, mirror. Behave like a mirror.
Professor, I have a question.
Go ahead.
Will there ever be a reflection across the y, the horizontal axis?
After, I explain. After, no, now. This is the last transformation, number 4. Okay? When you multiply, sir, when you multiply any function, suppose in the collection for the function, suppose square root, and you multiply negative square root, so es square root is a function like that, the graph. This is this. And negative square root is like that. Okay, another example, another example. I don't like this example. Suppose absolute value. Absolute value, you know, it looks like a B, like that. And what is the graph of the negative absolute value? It's a B, pero down. This is the function y equal absolute value, and this is the function y equal negative absolute value. Do you understand this? Super. Okay, so when you multiply any function times a number, be careful, because if the number is bigger than 1, we have a vertical stretch. Shook. See, the number is less than 1, so no less than 1 is in between 0 and 1. So no negative, and between 0 and 1, 1/2, 3/4, 0.5, 0.7, 0.75. So we are doing compressed, vertical compressed. Okay, like somebody pushing down and compress the figure. And si es -1, specific -1 is reflection. And we have combination. We have combination, of course. For example, we have y equal -6x squared. So you say, wow, wait a second. When you multiply by 6, is vertical stretch. And when you put a negative, we have reflection. So in this case, you stretch and reflection. Doesn't matter the order. Or you're reflecting first and stretching second. So suppose this is the basic parabola, no? When you multiply by 6, my parabola ahora is super narrow. 6, this is 6x squared, and minus is down. Make sense? Guys, everyone follow me? I know that this is complicated. Okay, zoom up or down? Like that or like that? You are in trouble, totally lost, partial loss. Come on, what happened? What's going on? Partial. Okay, partial. Okay. I try to explain now theoretical part. I promise that after that I bring 3 or 4 examples to illustrate very well the combination of everything. So don't expect to understand everything 100% in the first minute. So be patient and talk to me. Okay. Let's continue with the last transformation. The last transformation is, do you see the board? Do you see the board? Yes or no? Yes. Okay. Last transformation, number 4. Last transformation is horizontal. It's similar, horizontal. Number 4. We have only 4 is horizontal. And horizontal is, again, stretch, compress, and reflection. But different, completely different because it's horizontal. So we have the basic function, y equal f of x, the basic. And the new one after the transformation is you multiply one number but inside the parentheses. This is a new one. And remember, when you multiply the number inside, remember the operation inside is completely opposite. It's completely opposite. Therefore, the situation is different. Compress and stretch. When the d is greater than 1, let's suppose that the function is f2x. We have no stretch, we have compress. And we can see in this one now. horizontal compress. If D is in between 0 and 1, is stretch, horizontal. And if D is -1, it's a reflection, of course. D. Stretch. Si D is -1, es reflection. But it's reflection about the y-axis, not the x-axis. What means to be about x-axis, the y-axis? Suppose the parabola is impossible to see the effect. However, suppose the square function like that. This is the basic square root. I want to see the graph of the new one when you introduce inside the parenthesis, is synonymous to say inside the square root. This is the new one, get y equal -x. Okay, this is transformation. The transformation was this is -1 inside the parenthesis gets the same of the inside. Therefore, it's like that. The function after the reflection, but a reflection about or across y-axis. Super. Let me see in Desmos. I am not sure. I try to understand, but I am not sure. I am not sure. Let me try to see in Desmos. In Desmos now, to make sure everything is okay. Okay, Desmos. Now, look. Okay. This is not -1 anymore. This is +1. Because the transformation we study now is using D. And D is multiplier inside the parenthesis. Okay, entonces I propose you switching. That's the idea. This is the idea to another function. No parabola anymore. No parabola. Okay, I go. Wait a second. Let me remove this. I go to the square root function. This is a square root function. This is a square root function. Because in the parabola, you don't see very well the effect. Because suppose you are doing reflection of the parabola, stay the same. But in this case, no. Entonces, you move, for example, D to the positive value, you can see now, pay attention, focusing, get focusing. You see horizontal compress. Let me try. Ooh, do you see or no? Maybe it's confusing because you see some vertical stretch, but actually it's no vertical stretch because it's inside the parenthesis and you affect the x value, not the y value. Forget about see this effect look like it's accidentally. Okay, and suppose now okay, I move to the value less than 1. So you can see now horizontal stretch. Let me try. But suppose point A, look, do you see effect? Horizontal stretch. Somebody pull to the right. And see D is negative. Oh, reflection. Specifically, pure reflection is -1. Do you see or no? Do you see or no? Yes, absolutely. Okay. You understand everything? No, you don't. Why not? Because we need to see in the example in which you have more than one reflection. Suppose transformation, sorry. You have one transformation, two transformations. So you will be able to identification. For example, let's go to the example now. Let me try and do quickly example of the transformation. This is typical that you can see in the test. In the test, you can see one function is given. Wow. One function is given. One function is given. Suppose this function is given for x equal minus x minus pi square plus 3. can see the, sorry. Good. No se ve. Now? No? Switch it to bar. Yes and now? Okay. Number one step. Suppose that this function is given in the text. Number one step is identification. What this function belong to the what family of the function that we studied in college algebra. Remember, we studied in college algebra a constant, we studied in college algebra identity, we studied in college algebra square, we studied in college algebra cubic, we studied in college algebra square root, we studied in college algebra cubic root, and so on. What do you suppose belong to this? Huh? Quickly. Belong to the family of this. This is the basic. This is the mother. Why? Because it's a square. Look at that. This is the glue. And the rest is just transformation. Okay. Entonces, these belong to the family of y equal x squared. And you start for this. And you try to investigate how many transformation you can see. How many transformation we have in this original. How many? Entonces you see 1, 3 here, 1, 5 here, 1 -5, and -5, and 1 minus here. I can see, guys, and you try to do the transformation according to the order of operations. And the first operation you can see is this. So y, let me replace f of x for y. You know it's the same. Y is x minus 5 squared. We are doing this transformation. After transformation number 1. Transformation number 2 is change the sign. This is the horizontal, no? Horizontal shift. Because inside the parenthesis horizontal shift. In what direction? To the right or to the left? To the right or to the left? To the right. Very well. How do you know, Sergio? Get to the right. Because it's minus. When it's minus to the right, we studied that. And the second transformation, we have reflection. About x-axis. And we have one more transformation, 3 transformation, okay, is +3. And +3 is vertical shift. In what direction? CS3, positive. In what direction? 2 up. Very, very well. 2 up. Okay, now ready to do the transformation. We start for the basic parabola, que es the basic, the mother of this. Okay, 0, 0, suppose 3 points. 0,0, 1,1, and -1, +1. The first transformation, according to this sketch, was horizontal shift. Okay, horizontal shift. Okay, let me try to do my best. Horizontal shift. Horizontal shift means that any point on this parabola moving to the right 5 units. This point normally is 0,5. Now would be 1, 2, 3, 4, and 5. 5,0. This is the transformation number 1. It was horizontal shift to the right. This number, que es 1,1, now would be 6,1. Do you see how the x value change, however the y value stays the same? That was the supposition. And this was 4,1 here. And this is my new parabola after the first transformation. Everyone follow me? Everyone understand very well this? Okay. Okay. No, what part no, Jordan? Okay. You are clear that the transformation number 1 is x minus 5. So you're subtracting 5. I need to know by memory that this is horizontal shift to the right 5 units. So this parabola, the basic parabola is moving 5 units to the right. Point by point. Point by point means that the x component change. This 0 actually is not 0, it's 5, because 0 plus 5. And this 1 is not 1, it's 1 plus 5 is 6. And this negative 1 is not negative 1, it's negative 1 plus 5 is 4. And the rest of the y value stays the same. It's now confusing? It's still confusing or no? Jordan, don't be shy, come on. So, but go ahead. I don't want to hold, okay. No, pero no, see, I can solve the problem quickly. Yeah, I can. No? Okay, let's continue. So the transformation number 2 is the reflection. And the reflection is super easy because the reflection, the only thing you should do is, okay, of course you apply the transformation sequentially. This is the original. You apply transformation number 1. After the transformation number 1, you apply transformation number 2. No, go back to the original. No, of course, no. You apply sequence. So now it's change the sign of the y is reflection. So this is 1, 2, 3, 4, 5, stay the same, 5,0. But this guy, no. This guy changed the sign, but change the sign of the y. This point now is 6, -1. 6, -1. And this is 4, -1. 4, -1. And my parabola look like that. That was reflection about x-axis. Huh? I have a video on YouTube to explain this in detail with the animation, but it's okay. Finally, we have vertical shift, no? 3 units up, point by point. The transformation number 3 is now vertical shift up 3 units. Therefore, point by point, you transform it. This point get 5,0 now would be 5,3. 1, 2, 3, 4, 5, and 3. 1, 2, and 3. Why? Because you add in 3 in any y component. 0 plus 3 is 3. -1 plus 3 is 2. So 6,2. (5,3), and of course 4,2 again. And this is my final answer after the 3 transformation. From the original, look, I start for the basic. I create transformation 1, transformation 2, and transformation 3 gets the final, gets the combination of every transformation. Wow, the time flies. Jordan, if you want to stay here, yeah, I try to explain in particular, no? Or whatever you want by email. Okay, guys, time is over. Unfortunately, I have more examples. Maybe, I don't know, see if we have time or not. Okay. Okay. Switching to no sharing screen. Using my face now. Okay. Okay. Bueno, see you soon. I stop recording.